So, greeting everybody who's watching this video, and you're welcome. Today's topic, the 7th class review of the semiconductor class. So today's topic will be about the optical device. For optic, we may think something like the mobile device, like when we watch the videos for YouTube, and even the flashlight that we use it for the dark one or unvisible sight in the night. So anyway, optical means may be related with light. So light is one of the species of the energies. So let's guess. The light will be have three big modes. First, IR in flare that we can see this with our eyes. So something special or thermal cam or the IR in flare cameras can help to see the IR and for second the visible light from the red to the violet color we can see with our eyes. And lastly, ultraviolet or something than this ultraviolet wavelengths or frequencies. But as you can see here, when getting closer to the IR, the infrared, the energy is more down than previous, next to the one visible or ultraviolet. So, which means from IR to ultraviolet, the more energy will be increased, and it means the frequency will be more faster or harder than the previous one. So it means when we use the more higher energies or more brighter energies or light, like the ultraviolet, it means it will be a very harm to our body, human species or animals or any lives that just being directly hit by the light over the ultraviolet. So anyway, so how the light works with the device of the semiconductors? So first, let's get there is an excited electrons or carrier on the conduction band. The conduction band, the electron on the conduction band will want to return to the valence band as the time passes. So it will emit the light or heat by the energy and it will get back to the valence band. So in these situations, the excited electron will emit the energy and back to the valence band. So at this moment, the energy, the light will emit. So this is how the LED works. Light emitting device, diode. Light emitting diode. And for a second, the reverse case. If the carrier or the electrons at the valence band get energy from the exterior vectors, like a heat or something physical effect or light, then the electron will be excited and this electron will go up to the conduction band. So at this moment, the electron will absorb the energy and this will up to the conduction band. So this is how the solar cell or heater with light works. Okay. So for more details, see there is a P and N-type silicon stopped, and see this is the depletion region. Let's get. We just take a beam of the light to the PN junction diode here. We know light is one of the source of energy, so with the PN diode or junction get an energy, it will make a So it will make a pair of the hole and electrons. In short, generation of the carriers. So at this moment there will be a hole here and electrons here. So if they generate, they will want to get recombination to be stable. But for us, we need to use these carriers as the energy source. So if the generation happens, we need to apparently and fastly and as soon as possible we can depart them to the other side. So we inject the reverse bias. So it means for the n-type we bias the positive, and for the p-type silicons the minus voltage. So then hole will go here and electron will go to the plus sign voltage. So at this moment or situations, there will be a current induced by the carrier's move. And this is how we use the light as the energy source at these situations. Okay, and for second is the mass, the modes or the devices of the using the light as energy source, or emitting the light as using the electrons or carriers or current as energy. Okay, for first, LED. We know what is LED. So just getting the voltage in the plus sign for the positive voltage and minus for the negative voltage. Then it will emit the light. So this is how LED works. So in LED there is two methods of using this mode. For now we are using the AMOLED, AMOLED, PMOLED, PMOLED. AMOLED means active matrix OLED. Sorry, before starting this topic, let's see about what is OLED. OLED means organic LED. This means not using the P, of course, this LED using the PN diode, but it's something more effective and more good efficient to conversion the light, the energy to the light. So for most case, it will work like this. There's some transistors here. Okay, so here is some electrons and it passes. So we want to get back to the other side. There is a wall and it can't pass. Okay, so for the whole type, the same factor is when it passes, and it will want to go to the another factor of silicons. But if there is some wall that resists for the moving of the carriers, this will make the recombination more. So with this effect will make the more probability of the recombinations, and it will make the LED more effective. So at this structure of LED, we use the carbon integrated vectors or materials. So this is why we call it OLED, organic LED. And for organic LED, OLED, there is two methods for the active matrix and passive matrix. Okay, so for first, passive matrix here. It's something like the digital circuit logic, or actually logic circuit. Let's get here is diode here, diode. 3 by 3, totally 9 diodes of the second divisions flattened. So let's get first low, high, and rest of the low will be low. And for the burst of the vertical one will be high and left will be low. Then only this place will be emitted light since there is only high. Sorry here. Only bursting will be high, it will emit light, and others will be dark. Find the AND gate logic. Like this, okay? So, it will be very effective to show the images we want at once. But there is one factors. If we want to use about the AVI, the videos or moving images or animations, then the signals will be kept injected, but the sensors must reset the input, and so it means turn on, turn off, turn on, turn off. So it means there will be a very several consumption of the energies. And by the capping of the turning, turn off, and resetting, and setting the vectors and devices lightning, there will be very several consumption of the power, and there will be some overload of the circuit. Okay, and next for the active matrix. Active matrix is very simple, but maybe more complicated to make this one than the passive matrix. Let's get here is the transistor and capacitor here, and data line and VCC here. Okay, so this is the row selector of the logic device. At the row selector, select a transistor. Then the transistor will make a current flow by the gate voltage is induced, and the flow will collect for this. And here the capacitor will make a charge collected, and next, after this effect, maybe the system will want another image. Hey, I need something moving object. So there will be a change of images. So it means the image will be reset. But we know that the passive matrix, they will keep turn off, on, off, on, off. And for this one, look, here is the capacitors. So this capacitor will have the image remained, or some sectors to be remained as the color it was. So it will make more easy to remain the images as like a moving vectors. So okay, there is a main run. Next will be like this. So we maybe need to leave the head torsos. Okay, so remain these vectors will make the less consumption of the energies or power factors. Okay, so here was of LEDs. Okay, and for last, laser. Laser is the light amplified emitter. So what it means, for the LEDs, we just see a light keeping brightening, but laser means collecting these light vectors in one sequence and aim at once. So it will work like a superposition of the circuit. So let's guess. Here is the light flux, only one. Very weak. Second flux, very weak. For the wave, weak. And weak, but stronger and very strong. So the superposition of these vectors will be made the more strong energies of the light. So this is the method of the light, laser. So laser means making or amplifying the sequence of the happening of the light emission at once. So by the superposition, the more stronger light will happen. So this is how the laser works and made. Okay, so for the last three. CCD and CMOS. CCD means, okay, these two modes of the device is using for now the camera or mobile device that we use as a cam and even the recorders or camcorders. Anyway, so CCD means the charge coupled device. And CMOS, we know what it is, the complementary MOSFET. Okay, so for CCD, there is a light sensor here, and we just want to take pictures. Then the outside light will come here, and as the light hit by the sensor detects, and it will move forward typically. It will divide the colors into R, G, B, and by the RGBs, which one is more strong or more is lower or more is value of the constant, will make a pixel's color deserved. So there is a rush of the light sensors that detecting the opponents. So it will make the RGB each pixel by one color determined, and it will make an image in totally. So why is the CCD? Why is the charge coupled? There is, okay, so some charges gather and gathered. So what is the gather of the charges? Maybe a current. So by the charges just gathered, when it is enough big to move, it will be a current. It will make a current or signals to the sensors or the circuit. And finally, it will make an image or pictures. And for CMOS, maybe somewhat similar active mode, maybe the similar mode of how it works like a CCD. Okay, but for CMOS, there is some good factors. First, the power consumption is very low. Then CCD. Yes, if the CCD uses about 1000 milliwatt, maybe the CMOS will use about 10 milliwatt or lower than this one. Okay, about 10 years or 5 years ago, the CCD was had more good image or more pixels than the CMOS. But by the integration has been developed and more slow. So by the semiconductors market is more developing and scaling size is getting smaller, and the integration technique is more getting developed. The CMOS image sensor has more great pictures than CCD, and now the CMOS is more widely used in the camera and mobile device market. So okay, thanks for listening and goodbye.